So in this example, it has been given that this is a distributor which is supplying, that means sending end voltage is 240 volts, and following loads are connected, that means 20, 40, 35, these loads are connected to this distributor at a distance 150 meter, 50 meter, 80 meter. So these are the various ranges of the distances are given, and they have asked you what can be the receiving end voltage. Now it is a DC system, we have to always remember that sending end voltage is equal to receiving end voltage plus voltage drop. Sending end voltage is equal to receiving end voltage plus voltage drop. So we have to we know the sending end voltage. Our sending end voltage is 240. We have to calculate the voltage drop. So accordingly we will get the receiving end voltage. Now as we have done in the previous sum, we carry out the same thing. So first we will stratify our we'll make our sum in simple form, solution in a simple form. So we'll say section, we'll say current in that section, we'll say resistance of that section. So this will make our sum in the easiest form. So they have given again the resistance of double run is 0.1. So for per conductor it has to be made half. Now let us have the calculations for the double end, and then we'll make it for the single one. So section is, now say AB is first section, then second for AB the current is 20 amperes. See, for the section AB, what might be the current? 20 amperes plus 40 amperes. So if you see, this is 60 plus 35, that is 95 plus 25, 120, 130, 160 and 190. This is the total, that is current. AB is handling the current section of 190 ampere. So if you again see, you can add this and you will find the total current is 190 ampere. Now what is the resistance? So for the double run let us calculate. So see, this is 150 meters, but the total feeder is of 500 meter. If you calculate the total length, you will get the 500, and the resistance of double run you have been given as 0.1. So that means you can simply say that if for 500 meters I have been given 0.1 as a resistance, so what might be my resistance for 150 meter? So we will get 150 into 0.1 upon 500. The same thing we have done here. Now this will make our calculation easy. Sorry, here the total comes to be 180. If you make the total, this will be 180. Now on the same basis, if you calculate the value of current for the section BC, just it will be 160 amperes, and the resistance of the section, so it is 50 meters, so 50 upon 500 into 0.1. Similarly, if you do the calculation for section CD, you will find that total current will be 120 amperes, that is handled by the sections CD, and if you see this CD, it is 80, so we'll say 80 upon 500 into 0.1. So if you go for DE, you will get the current of, for the section DE, what current it is handling. If you see 25 plus 10 plus 20 plus 30, this much amount of the current it is handling. Section DE will be handling the current of 85 amperes, and since DE is 40 meters, so we write 40 upon 500 into 0.1. Similarly, if you consider for EF, so EF is a section which is handling the current of, say, if you are seeing EF, so this will be 10 plus 20, that is 30, 60 amperes. So EF will be handling the current of 60 amperes, and the length of EF is 17. So we'll write here 70 upon 500 into 0.1. And if you see after EF, what comes is FG. So FG is the section, if you are considering FG is the section, and this is handling the current of 50 amperes. So this is 50 amperes, and if it is a 50 amperes handling, and its length is 60 meters, so we'll write here 60 upon 500 into 0.1. Now last section, that is G, we'll say H here. So section GH, if you consider the section GH, so GH is handling the, GH will handle the current of 30 amperes, and its resistance will be, its length, as its length is 50 meter, so 50 upon 500, so I'll write 50 upon 500 into 0.1. Now we'll simply make the calculations and we'll calculate the value of resistances. So these are all the values which we have calculated. So for this section AB, the resistance is 0.03. For this section BC, it is 0.01, and so on. Now what is our next step? Next step is to calculate the voltage drop, and voltage drop we will calculate in our predetermined formula, that is I into R. So we will multiply current with this resistance. So this comes to be, say, 180 into 0.03. If you do 180 into 0.03, it comes to be 5.4. This is 5.4 volt. Now if you multiply 160 into 0.01, you will get 1.6. Then if you multiply 120 with 0.016, you will get the value as 1.92. Then if you multiply 85 with 0.08, you will get the value as 0.008. Sorry, it is 0.008. 85 into 0.008, you will get the value as 0.68. Then if you multiply 60 with 0.014, you will get the value as 0.84. If you multiply 50 with 0.012, you will get the value as 0.6. If you multiply 30 with 0.01, you will get the value as 0.3. So this is IR, this is voltage drop in volts. Now total, what is our next step? Next step is to calculate the total voltage drop. Now how I should calculate the total voltage drop? So I will simply add all these drops. So we have to write voltage drop across the section, voltage drop in AB plus voltage drop in BC plus voltage drop in CD plus voltage drop in, after CD comes to be DE plus voltage drop in EF plus voltage drop in Fg plus voltage drop in GH. This is how I have jotted down all these. That means 1, 2, 3, 4, 5, 6, 7. Right? So this is 1, 2, 3, 4, 5, 6, 7. All the drops I have jotted down. And now this value comes to be, so this comes to be 11.34 volts. But this is for the double run. So for single conductor, this will be for voltage drop per conductor will be equal to 11.34 upon 2, and this comes to be equal to 5.67 volts. So now we'll use our formula, and our formula is sending end voltage is equal to receiving end voltage plus voltage drop. So our receiving end voltage is equal to sending end voltage minus voltage drop. So receiving end voltage is VR and our sending end voltage was 240 volts and our voltage drop per conductor was 5.67 volts. So per conductor, whatever we get the value is 234.33 volt. So receiving end voltage will be equal to 234.33. This is regarding the how to calculate the voltage drop for uniform loading. In the next session, we'll see how to calculate the voltage drop across the distributor in non-uniform loading. That means we have to consider there the resistance inductances. That is all. Thank you.